Welcome to The Explainer. Today we are diving deep into one of the most famously complex and sometimes frustrating processes in all of programming, building a C++ project.
You know that feeling, right? You're just staring at a cryptic build log or maybe a linker error that makes no sense, and you're just wondering what on earth is actually happening under the hood. Well, if that's you, you are in exactly the right place. So let's really lean into this analogy, thinking of the whole build process as a symphony. You've got your instruments, a musical score, a conductor. It's actually the perfect way to make sense of all the different moving parts.
First things first, let's meet the musicians in our orchestra. These are the core tools, the individual instruments that have to work together perfectly to turn your human-readable code into a program your computer can actually understand and run. It's basically a 4-stage assembly line, and each step has a super specific, and I mean absolutely crucial job to do. It all starts with your simple text files and ends with one single ready-to-run executable. Let's break down what each of these players actually does. The whole process kicks off with the preprocessor, and here's the wild part. This tool doesn't even understand C++. Seriously, it's just a simple text manipulator. Its most important job is to handle that #include directive you see everywhere. And it does it by literally copying and pasting the entire contents of a header file right into your source code. And this is the direct result of that simple little copy-paste operation. It's kind of insane. You can have a tiny 10-line file, you add one single standard library header, and boom, it explodes into over 20,000 lines of code that the compiler now has to chew through. This is what we call header bloat, and it's one of the main reasons C++ builds can feel so incredibly slow. Okay, so after the preprocessor has made its giant text file, the real star of the show, the compiler, steps in. It takes that massive file, checks it against all the rules of the C++ language, and translates it into low-level assembly code. Then the assembler takes that human-readable assembly and turns it into pure binary machine code, creating these little intermediate chunks called object files. And finally, the linker acts as the grand unifier. It grabs all those object files, plus any external libraries you're using, and stitches them all together into the final performance, a single executable program. Now, you can imagine, right? Trying to tell each of these instruments what to do one by one for a big project? It would be pure chaos, an absolute nightmare. So over the years, developers created a score, the build system, to automate and orchestrate this whole complicated dance. And that score has evolved a lot. It started way back in the 70s with Make, which was a pretty basic conductor that just looked at file timestamps. Then we got meta build systems like CMake, which are more like a composer. They write different scores, like a Makefile or a Visual Studio project for different platforms. And now we have these hyper-fast conductors like Ninja, which are just built for pure execution speed. And this really is the key takeaway here. It's a total shift in thinking. We've moved away from writing these fragile step-by-step scripts that tell the computer how to build everything. The modern way is to just describe what we want to build, like an executable here, a library there, and we let the build system figure out all the messy, platform-specific details for us. But, a modern symphony isn't always just the core orchestra. A lot of times, you bring in guest artists. In the C++ world, these are the thousands of amazing third-party libraries we all depend on. And getting them to play nicely together, well, that's a whole other challenge. This quote right here, this is the very definition of dependency hell. Just think about it. For one library to work everywhere, you might need dozens of different pre-compiled versions to cover every possible combination of operating system, compiler, architecture. It's a combinatorial explosion. Doing this by hand is pretty much impossible. So to try and solve this mess, package managers showed up, and they generally follow two main philosophies. On one side, you have tools like Conan, which are all about finding and downloading pre-built binary packages that match your system. On the other side, there's Microsoft's vcpkg, which takes a different approach. It gives you a huge catalog of libraries and just builds them from source right on your machine, integrating beautifully with CMake. But hang on, what if the problem isn't the conductor or the score, but the music itself? There's a revolutionary change to the C++ language, C++ 20 modules, and it promises to simplify this entire performance in a really big way.
And I'm not exaggerating here. This isn't just some minor tweak or another new tool. We're talking about a fundamental reimagining of how C++ code is structured, shared, and compiled. It's designed to fix the problems we talked about earlier right at the language level. So get this, instead of that clunky textual copy-paste thing from #include, the one that causes all that header bloat, modules give us a true intelligent import. The compiler can import a pre-compiled module interface, a summary of what's available, without having to reparse thousands and thousands of lines of code every single time. The promise here is for builds that are way more robust and, most importantly, incredibly fast.
So yeah, the orchestration of a C++ build is undeniably complex. There's no doubt about it. But it's also a symphony that is constantly evolving, always getting smarter and faster. The arrival of C++20 modules isn't just a new instrument, it feels like a whole new composition. And that leaves us with a final, very hopeful question. Will this finally make the C++ symphony easier for everyone to conduct?